Welcome to Decoding Autism Now, where we bring you science-backed insights into the biology behind autism. I'm Dr. Elise Martin, and this is episode 8 of our 24-part series based on the book Unlocking the Rhythm of Digestion in Autism by Quay Stoner. In Chapter 7, we uncovered how low stomach acid can ripple outward into digestion, immunity, and brain chemistry. But the cascade doesn't stop there. At the center of this next chapter lies a powerful regulatory hormone, somatostatin. Often called the body's master off switch, somatostatin silences acid production, blunts hormone release, and slows down regeneration repairs. In autism, its overexpression locks the system into survival mode instead of repair. A somatostatin is a peptide hormone produced in the stomach, pancreas, and brain. Its normal role is to maintain balance, turning off acid once digestion is complete, preventing overactivation of hormones, and conserving resources. But when somatostatin is chronically elevated, the balance is lost. Instead of being a safety brake, it becomes a blockade, shutting down growth, hormone cascades, and even neurotransmitter production. Somatostatin is elevated not only by acid fluctuations but also by chronic stress, inflammation, and opioid peptides, a triple signal common in autism. When somatostatin rises too high, three major processes are affected. 1. Stomach acid is suppressed further, worsening hypochlorhydria. 2. Pancreatic enzymes and bile release are reduced, impairing nutrient absorption. 3. Growth hormone and thyroid signaling are blocked, slowing development and energy metabolism. What began as a digestive imbalance now cascades into growth, immunity, and behavior. Somatostatin doesn't just affect digestion, it rewires neurotransmitter pathways. High somatostatin reduces the availability of serotonin and dopamine precursors, leading to mood instability, sleep disturbance, and poor motivation. In children, this may look like anxiety, withdrawal, or rigid behaviors. Research links somatostatin overexpression to reduced hippocampal activity, impacting memory, learning, and emotional regulation. Somatostatin also acts as an immune modulator. In normal amounts, it quiets inflammation. But in chronic overexpression, it oversuppresses the immune system, leaving children vulnerable to infections, while paradoxically fueling autoimmune patterns through imbalance. Somatostatin receptors are found on nearly every immune cell, meaning this single peptide can broadly silence or distort immune activity. One of the most concerning effects of excess somatostatin is its suppression of growth hormone and thyroid function. This contributes to short stature, delayed puberty, low muscle tone, and chronic fatigue. Parents often see stalled developmental progress or regression at times when growth signals should be peaking. This creates a vicious cycle. Low stomach acid raises somatostatin. High somatostatin lowers stomach acid even further. Meanwhile, nutrient absorption drops, neurotransmitters dwindle, and energy metabolism falters. The loop tightens until even small stressors, like infections or dietary slips, cause major regressions. While somatostatin is rarely tested directly, its footprint can be seen in other lab markers. Low stomach acid or pancreatic elastase on stool testing. Low IGF-1 reflecting suppressed growth hormone activity. Thyroid markers showing low T3 despite normal TSH. Deficiency in zinc, B12, and amino acids despite adequate intake. Together, these markers point toward an invisible but powerful blockade. Even without labs, patterns emerge that suggest somatostatin dominance. Children who stop growing or lose milestones. Ongoing reflux despite acid-suppressing medications. Persistent fatigue, anxiety, or social withdrawal. Fragile sleep with frequent waking. These red flags deserve closer attention. Addressing somatostatin overexpression is complex, but possible. Strategies include restoring stomach acid through nutrient repletion, supporting pancreatic and bile flow, and stabilizing neurotransmitter pathways. Some integrative clinicians explore targeted therapies that reduce somatostatin signaling while strengthening growth hormone and thyroid function. Emerging research suggests that polyphenols, zinc carnosine, and B12 support may indirectly lower somatostatin while restoring acid production. Somatostatin is just one node in a much larger network. Its overexpression shows how the body adapts to stress signals, but at a steep cost. By recognizing its role, we shift from chasing symptoms, like reflux, fatigue, or stunted growth, to addressing the root chemistry driving them. To recap, somatostatin, the body's off switch, becomes a barrier when chronically elevated. It shuts down stomach acid, enzymes, growth hormones, thyroid signals, and neurotransmitters, trapping the body in a state of stagnation. In our next episode from this series, we will explore a fascinating new theory about the high male ratio in autism. I am reasonably certain that you have not encountered this theory in the past, as it is new and unpublished in any medical journals at the time of this video. It is very exciting to be first to review such a novel concept. Once you review and understand the theory, you will be asking what took so long to see through the fog. This is the book chapter that excites me the most. This series is based on the book Unlocking the Rhythm of Digestion in Autism, available in paperback, hardback, and digital formats on Amazon. If today's insights helped you see the biology behind the behavior, share this episode on your social media and with others. This is how you can personally make a difference that benefits others. For future episodes, subscribe to our channel Decoding Autism Now, where science meets strategy and where we make the invisible visible. Final thought of the day. Sometimes healing requires less stimulation, not more. By learning when the body is stuck in the off position, we can open the door back to balance, growth, and resilience.